So today I will be talking about hexadecimal numbers. How do we get to a number or a code that looks like this? In order to understand the hexadecimal numbers or the hexadecimal code, as your own use case might be, we have to understand other number systems, like the popular ones like the decimal, for instance. Now we also have the octal based system and the binary based system. These are the hexadecimal itself. It's a base 16 number system. How does this work? So let's start with the decimal number system. Now the decimal number system is the normal number system, which is the base 10 we normally use for counting. Decimal number system has a distinct figure of 0 to 9, which is just 10 digits. 0 to 9. So it's just 10 digits that form every number that you see under the base 10 system. Now, same way for the octal system, the figure that forms the whole figures you can see within a base 8 number system is 0 to 7. Now, same way for binary, which is the base 2 number system, is just 0 and 1. How does this work? Now, using the decimal, for instance, now when you count from 0 to 9, the next number after 9 is 10. But how did we get 10? We go back to the beginning and then pick 1 and add 0 to it. Pick 1, add 1 to it. Pick 1, then add 2 to it. So that's how we got 10, 11, and 12 continuously. That's how we got 20, 30. We keep coming back to pick the next character and adding every character to it again. So that's easy, yeah? So let's come to base 8. Now when you count from 0 to 7, the next number after 7, it's 10. Yeah, because when you get to the last digit, you go back and pick again and start. So when you start 10 and you count again to 17, the next number is not 18. You come back again. So the next number after 17 is 20. So same thing for the base 2 system. Then you have 0 and 1. Then after 1, you have 10. Coming to the base 16, which is the hexadecimal, it is a bit different because for the previous ones we talked about, they are usually within the number of figures that we know. But now, when you count from 0 to 9, you just have 10 digits. But we say it's base 16, yeah? So that means you need 16 distinct figures to form every other number under the base 16 system. Now, what do we do in this case? Now, after 0 to 9, we decided to add alphabets in order to make it 16 characters or 16 figures. So after 0 to 9, you have A, B, C, D, E, F to make it 16. Yeah? So at this point, when you count from 0 to 9, you count to F. Now when you get to F, you now come back. Right? So when you come back to 1, you do from 11 to 19. When you get to 19, you don't get to 20. Now you now get to 1A, 1B, 1C, 1D, 1E, 1F before you go back and start from 20. Yeah? So that's the way it works for hexadecimal. So, and that's why you end up with numbers that look like this, like this, because of the combination of these characters and numbers. Yeah? So if you work with colors on the computer, you're a designer, you must have seen hex codes, and any other place you must have seen hexadecimal numbers. This is why they look the way they look. Thank you, and follow for more.